In the next lesson, we're actually going to combine the law of sines with the law of cosines and talk about when do we use each. So just a reminder, and you can write this down if you want, but I've got different ways that I'm gonna talk about it. When do I use the law of sines? A reminder what the law of sines look like: sine of A over A equals sine of B over B equals sine of C over C. But we're going to use that. When do we use it? Use when given, and we're going to write it like this: angle, side angle, or angle, angle, side. So when you're given two angles and a side, or if you're ever given angle, angle, side. That's the three scenarios when your law of sines is going to work. Now, law of cosines, a reminder what the law of cosines look like from the previous lessons. It says law of cosines used when given side, angle, side, or if you're ever given all three sides. That's when you can use your law of cosines. Now, reminder, what do we mean by side, angle, side? If you've got a triangle and you're given maybe this side and you're given this side, and the angle, notice the angle's in the middle, you're given the angle that's in the middle of those two sides, that's when you're going to use this scenario would be a side, angle, side situation. Side, side, side means you're given all three sides. What I would rather you do, though, is just attempt law of sines. If law of sines works, then use law of sines. It's hands down much easier than law of cosines. So number one says indicate the law and find the missing measures. So let's see if we can use the law of sines. So we've got the sine of 39 over x equals. Well, do you notice that we don't have any other angles? You can think of it like this. Here's another good way of doing it. If you have an angle that's across from a side, you're given an angle across from a side, you should be able to use law of sines. So here we have this angle, and that's the only angle. We don't have the side across from it, so we're going to have to use the law of cosines here. And our law of cosines looks like this: a squared equals b squared plus c squared minus 2bc times cosine of a. We'll let this be my angle A. So we have x squared equals B and C are 9 and 19. And I'm not going to go through the process of actually solving this. I'm going to go straight to our answer, but just keep in mind that you can type all that in. Don't forget the square root. We actually solved them last section, actually the last two sections. So if you want to check yourself, I'm going to go straight to the answer. X is going to be about 13.3 here. 13.3, there we go. The second one, again, we're going to try to use our law of sines if at all possible. Now, we have two angles, so anytime in a triangle you have two angles, remember that you really have all three angles. The three angles add up to 180, so you have a 77 and a 54. Let me add that together. That's going to be 131, which leaves you with a 49-degree angle. So the next question is, do you have an angle-side relationship? If you have an angle side, then an angle and an opposite side, that means you can use law of sines. And you do. You have a 49, which is across from a 30, so we should be able to use law of sines here. So let me check that. So the sine of 49 over 30 is equal to, we're looking for x here, so the sine of 54 over x. All we've got to do now is multiply these two, divide by the sine of 49, and we get that x is about 32.2. Next problem, again, ask yourself, do you have an angle-side relationship? And it is obvious here that you have the 112 and the 18, which are across from each other. So this is a law of sines problem. So the sine of 112 over 18 equals the sine of x. And notice here that you're looking for an angle, so you are going to have to do the inverse sine. To get x by itself, you're going to move the 8 over, type all of this in. Then you will eventually, to get rid of the sine, you'll have to do inverse sine. And once you do that, you're going to get that x is approximately 24.3 degrees. But just a quick reminder that anytime you use law of sines, you don't have to worry about with cosine, so it's really nice. But anytime you use law of sines, there are two possible answers. There's going to be a first and a second quadrant answer. So to find the second one, we're going to take that away from 180. That's going to give you 155.7. Checking that, we already have one obtuse angle, so there's absolutely no way that a second obtuse angle is going to work. So 24.3 is going to be your only answer. Now the side-side-side relationship, this one's always really obvious. You don't have, you have an angle, or you're looking for an angle, but you don't have it. So you don't have an angle-side relationship to where you're given the angle and the side, so this is going to have to be a law of cosines. You have a squared equals b squared plus c squared minus 2bc times the cosine of a. And what we're going to have to do is the angle that you're looking for is going to have to be your angle A. So we plug in everything. You have 7 squared equals 5 and 6 are your B and C. It doesn't matter which is which. 2 times 5 times 6 times the cosine of A. You're going to move 5 squared and 6 squared over. You're going to divide by negative 2 times 5 times 6. Your answer. And then to get A by itself, you're going to do the inverse cosine. And you're going to find out that angle A is going to be approximately 78.5 degrees. And again, what's so nice about law of cosines, we don't have to worry about that whole first quadrant, second quadrant stuff. Because honestly, first quadrant, if it's positive, it's first quadrant. If you do all this work right here, you subtract, you divide by this, and you get a negative answer, then it's second quadrant. However, when you're dealing with sines, again, sine is positive here and it's positive here, so that's the reason you're going to have two possible answers when you're dealing with sines. Next up, we're actually solving triangles. Now, it says to solve a triangle means to find all missing sides and angles. Use the information given to solve each triangle, round all answers to the nearest tenth. So they say you got a triangle ABC, and we're hoping for not the ambiguous case, because then we might have two possible triangles, but I'm hoping, since they're only giving us one set of blanks, that we only have one triangle to worry about. So we have A, B, and we have C. Have angle A is 47 degrees. Angle B is 52 degrees, which is nice because that means we already know what angle C is. Let's go ahead and do that. 47 and 52 is 99, so that leaves me with an 81 degree angle. So all of a sudden I have all three angles. They give you that B, let's see, AC, which would be side B, is 13. And we're asked to find the other two sides as well. Obvious, this is going to be a law of sines because you have an angle that's across from a side. So the sine of 52 over 13 is equal to, it doesn't matter which you find first, we'll find this one, the sine of 47 over x. Again, I'm not going to go through all the steps of solving this. All you're going to do is you're going to take 13 and multiply it by sine of 47. If you're having issues here, go back and watch the previous videos. Multiply these two together, take your answer, divide by the sine of 52, and you're going to get x is going to be approximately 12.1. And then to find your other side. Now, let me give you a word of advice. We know that this is 12.1 right here now. However, there's a problem with that. That is a rounded answer. If at all possible, we want to stay away from using a rounded answer to find another answer. So when you set this up to find y, these are not rounded answers. So why not say again, the sine of 52 over 13, this is going to be law of sines, is equal to the sine of 81 over y. To solve this again, we're going to take 13 times the sine of 81, multiply them together, divide your answer by the sine of 52, and you're going to get y is approximately 16.3. So that's going to be 16.3. And I want to show you a good check here one more time. Smallest angle is 47. Look what it's across from, the smallest side. The next smallest angle, just a little bit bigger, is 52, which is across from a side that's a little bit larger. And then the biggest side, 81, or biggest angle, 81, is across from what is the biggest side. So AB here is 16.3, and BC gives you a value of 12.1. Okay, next problem. In triangle XYZ, so let's draw triangle XYZ. XYZ. XY is 29. YZ is 22. And XZ is 21. So we have a side relationship. So no angles anywhere to be seen. So there's absolutely no way you're going to be able to use law of sines because, again, you need an angle and a side across from each other to use law of sines. So we're going to go automatically to the law of cosines. A squared equals B squared plus C squared minus 2BC times the cosine of A. And again, we don't have any A's. So whatever you want A to be, put it there and use this formula. Little a is going to be 21 now. Little b and c, it doesn't matter which is which. So that'd be 22 squared plus 29 squared minus 2 times 22 times 29 times the cosine of what we're looking for. And I'll call it our x here. Well, that's going to be confusing because there's a side x. You can call it cosine of question mark. But just keep in mind that this a value up here, now that you've got it plugged in, is actually y. So as you type all this in, make sure you move the 22 squared and the 29 squared over first by subtracting. Once you take this minus 22 squared minus 29 squared, you'll then divide by this. Once you do all that work, then you're left with the cosine of the angle that you're looking for. To get rid of cosine, you're now going to do the inverse cosine. Once you do all that work, and we're actually finding angle y, the measure of angle y to do that. I know we called it A momentarily, but now that I have it plugged in, the measure of angle y I find to be about 46.2 degrees. Now I have a problem here because what I really would like to do is I would really like to use, since I now know that this is 46.2 degrees, I'd really like to use that angle side relationship and use the law of sines. But let's write this down. Let me use a different color marker here. We use black. The sine of 46.2 over 21 equals, I don't know, we'll find x maybe next. The sine of x over 22. And here's the problem, is that 46.2 is not the answer to that previous question. 46.2 is a rounded answer for the previous question. So what I advise you to do is, as you work these problems out, do one of two things. Either store this exact answer in your calculator or write out this answer to maybe 6 or 7 decimal places so that it doesn't mess this answer up by using a rounded answer to find another answer. And as I was doing that, I noticed that I actually misrounded this last one. That should have actually been 46.1 degrees. So make sure that we make that correction there. So therefore, my actual number that I should be putting in right here is not the sine of 46.1 or 2. It's this large number. So as you type it in, now type in 22 times the sine of 46.14863314, which is all the numbers that would fit on my screen, divided by 21, and that gives you, of course we have to move this over, that gives you what the sine of x is equal to. Move the sine over by doing inverse sine, and you'll get that that angle x is approximately 49.1. And I mistyped that. Make sure, I believe that's supposed to be a 21. It looked like a 27, so when I typed that in, it looked, it messed me up. So I get about a 49.1 degree. To be exact, it was actually 49.06727542, and it would round to that. So here are my other two angles, the exact versions of them. But now it's not going to be as hard to find that z, because since I have two of the angles, which I was not overly cautious. I should have been. Here there was actually was there two different values that I could have used for the x? Would 131 degrees also would have worked? It looks like it to begin with. However, when you did plug that in, could X be 131 degrees? Well, think about it. 46 degrees was across from 21. So across from 22, could I have a 131 degree angle? Well, you got a 29 over here, which is going to be even bigger than that. So there can't be a 2 up 2. So you're going to be able to throw that 131 out. So what you can do to find angle Z now, simply add these two together and you're going to get 95.2, which is going to leave you with an 84.8 degree angle for your third angle. Okay, number 7, in triangle DEF. So let's draw our triangle. D, E, and F. You're given that F is 72 degrees. You're given that DE is 15. So automatically, before I put anything else, this is a law of sines because you have that angle side. EF is 12. And again, the only issue that we have with law of sines is we're going to have to worry about that possible multiple answers, that ambiguous case. So we have the sine of 72 over 15 is equal to the sine of, and it really doesn't matter which one you find first, we'll find D first, over 12. Actually, it will matter because we don't have this third side. So it'd be hard to find E before you find D. We're going to move 12 over by multiplying. Type all of this in. We're going to get rid of sine by doing the inverse sine once we get it all typed in. And that tells us that angle D is going to be approximately 49.5 degrees. So D is about, the measure of angle D, 49.5 degrees, the measure of angle D. So there we go. So this one's going to be a little bit easier than that last one, hopefully here. Now we do have to check for that second, since it's law of sines, the second angle would be 130.5 when you take that away from 180. But you've already got a 72, so that one's not going to work. We can throw it away. So now you have a 72 degree angle, a 49.5 degree angle, which is this angle right here. Add those two and take them away from 180, and that's going to give you the measure of angle E, which is about 58.5. So now in order to find the last piece of information, which is this side length down here, we're going to use, and again, I have an issue here because 58.5 is a rounded answer. If you want to get a more exact answer, we're going to have to go back up to this 49.5, and we really need more of an exact answer than 49.5. And there you have what that is 49.53876676, which makes the measure of angle E not 58.5, but 58.46123324. And there's your exact it's still approximate, but there's more decimals. So now that's what I would use to actually find the measure of X, just to where it's a little bit more exact. So you have law of sines. We're going to do the sine of 72 over 15 equals the sine of, since we're looking for this side, we're going to have to use E, which again, I'm going to put 58.5, but as I type it in, I'm going to type in that long answer down there. And then once we type that in, again, we multiply 15 times the sine of the 58 point stuff. We're going to divide that by the sine of 72, and that tells us that X is going to be about 13 13.4. So DF is about 13.4. Okay, number 8. In triangle RST, and draw my triangle here. We have R, S, and T. It says that R is 55 degrees. RS is 17 and RT is 9, which is automatically not a law of sines because you don't have an angle side relationship. You only have one angle and not the side across from it. So we're going straight for the law of cosines that says a squared. And in this case, we'll just make this R look like an A right here. So this would be our A, little a. So we have a squared equals b squared plus c squared, and that'd just be the other two sides, minus 2 times b times c times the cosine of the angle, which is 55 degrees. But again, we know that that is actually an R instead of an A. So there's everything typed in. To figure out what x is, again, we simply type in all of this. We take the square root to find out that x is going to be about 13.94580978, which for the sake of ST here, we can call that 13.9. Now, why did I put all those decimal places? Because I'm about to use that for that side, along with the law of sines that says, let me change colors, the sine of the angle over, well, the sine of the angle over the side across from it, 13.9. But again, I'm not going to use 13.9. I'm using 13 point that equals, and then whatever you're looking for. Let's find t, I guess. The sine of t over 17. So again, I move the 17 to this side. I type this thing in. That tells me what the sine of t is equal to find out what t is. Once I get that typed in, make sure that I do the inverse sign to move that sign over. And I find out that the measure of angle t is equal to, it says that it's about 80, we'll call it 87 degrees. But I have a problem here. Let's talk about this problem. Because notice that I actually have all three sides of this triangle now. So this triangle is pretty set. If you got three sides, then we know that there's only one triangle that we can create given three sides. So there's not going to be an ambiguous case here, but I've got a problem because 87 and 93 will both actually work on this problem. Because if you figure out what angle S is, on top of that, it's going to give you the other two values that are also going to work. So what I'm going to do is, since I'm given all three sides here, is I'm going to go back and instead of working that law of sines like I just did, I'm going to work that problem again because I know that there can't be two possible triangles in this case. That hinge theorem is not going to work because I've got this side angle side relationship or the side side side. I've got all three sides, so there's an exact answer. So since I have all three sides, what I'm going to do in order to find angle T, because I do want to remind you that 87 or 93 both should work for this triangle, but one of them is going to be an answer that I can throw out. And let's see what that is. So I'm going to go back and work this same problem using the law of cosines. And we'll say, for the sake of doing this problem, that we're looking for angle T here. That's going to be like my A. So I have 17 squared equals, so that's A squared equals 9 squared plus the other side was about 13.9 squared minus 2 times 9 times 13.9 times the cosine of, in this case, we're looking for angle T. And as I work that, we move the 9 squared over, move the 13.9 squared over. By subtracting, we divide by this. Then we take the inverse cosine to figure out what T is. It gives me actually that angle T is 93 degrees. So we know for a fact that angle T has to be the 93-degree angle. And since you have 93 and 55, that's 148. That leaves you with a 32-degree angle for angle S.